Today we're taking a look at measures of variation in section 3-3. Our learning outcomes include the following. Number 1, determine the range, variance, and standard deviation of both a sample and a population. Number 2, apply the range rule of thumb to estimate the standard deviation for a sample. Number 3, apply the range rule of thumb to determine the minimum and maximum usual values for a set of data. Number 4, apply the empirical rule to determine the percentage of data that will fall within 1, 2, or 3 or more standard deviations of the mean for a normal distribution. Number 5, apply Chebyshev's theorem to determine the minimum percentage of data that fall within 2 or more standard deviations of the mean for any distribution. So as you can see, we have a lot to cover. So to lead us into our topic of variation, measures of variation, I want to take a look at an example. I have been a Germana for slightly more than 20 years, and one winter when my office was located at Locust Grove, this is when Germana only consisted of the one campus, I recorded the temperature in my office each day when I arrived. So if I told you that my mean temperature in my office was 72 degrees Fahrenheit for that week, would you think that my office was a comfortable place to work? Possibly. 72 degrees sounds like not a bad temperature. But truthfully, here are the temperatures, and what you have to realize is that at the time Germana didn't have a lot of activities on Saturday, so they on Friday they would turn off the heat in the late afternoon, and then you'd come back to school on Monday, and the office was, this particular week, 52 degrees. Okay, we complained, and so they turned the heat on, so by Tuesday it was up to 64 degrees. And then by Wednesday we were up to 72 degrees. Thursday the heat was really cranking out, so it got up 86 degrees. And then it continued to crank out, and on Friday it was at 86 degrees. So as you can see, I was really only comfortable on Wednesday. So I only had one day of comfort in that week where the mean temperature was 72 degrees. So what is the measure of center 72 degrees not telling? It's not telling that the temperature ranged from 52 degrees to 86 degrees. So what I wanted you to do now is to pause the recording and double check to make sure the mean does actually come out to 72 degrees. Figure out the median, the mode, and the mid-range for these 5 values. So we can look at the other measures of center before we move on to talk about the measures of variation. So stop your recording now while you calculate or find the answers to the median, the mode, and the mid-range. Okay, I'm assuming you've come up with your answers at this point. So as you look for the median, it's the middle number, and these are already arranged in numerical order. So it turns out the median and the mean are both the same. The mode, however, we have two 86s, so the mode is 86 degrees. The mid-range, we need to add our 52 and our 86. And we want to divide that sum, 138, by 2, and we get 69 degrees. And so as I look at these 3 figures, 72 is comfortable, 72 is comfortable, 86 is too hot, I will have to admit that. 69 is perhaps a little bit cool if sitting at a desk working. If you're walking around teaching class, that kind of thing, it wouldn't be bad at all. So we're getting a little bit of information from the measures of center, but particularly the mean, the median, and the mid-range, they're all clustered pretty close. So how can we come up with some information that will explain why I was not comfortable that week? Well, what we do is we take each data value, which we refer to as an x, and we subtract the mean from it. So if I take 52 minus 72, I get 20. If I take 64, and that is a negative 20, I should say. If I take 64 minus 72, then over here, minus 64, was going to get a negative 8. If I take 72 minus 70, and 86 minus 72 is, what, 14? Positive 14. And so that would also be a 14. Now we're going to square those. And 64 and a 0 and 14 squared. 196. So we're going to use this table to determine what is called the standard deviation. Now, before we complete that, there's an easier measure of variation, is the range. And that would give a little bit of information in terms of how uncomfortable I was that week. You take the high value minus the low value, so I'm going to take 86 minus 52, and that gives me 34 degrees. So there was a range of 34 degrees during the week, which when you're working in an inside office would be quite a bit. So that would give you a little bit of an idea that I was uncomfortable that week. Measures of variation are also called measures of dispersion. So you can see here where I calculated the range. 86 minus 52 equals 34. Now the other measure of variation that we will be using quite a bit is the sample standard deviation. And you'll notice there's a slight difference between the formula for the sample, and again with sample standard deviation you're seeing an S for the formula. The population uses a uses a lowercase sigma, and notice here we're dividing by n, whereas with the sample we divide by n minus 1. The n, subtracting that 1, is a correction figure to try to make it a little bit more accurate. And so let's go back to our table. Now, in order to, and I really kind of am going to have to jump back and forth between these. The sample standard deviation is the one we're going to look at right now, is the sum of all the x's minus, and that should be an x bar, so make sure you correct that on your notes. All of your x's minus the mean squared, and then we add them up. Then we divide by the n minus 1, and finally we take the square root. Okay, so I have the x minus the x bar squared column. So I have to add that up. So 400 plus 64 plus 196 times 2. I'm getting 856. So now using going to have 856, and it was 5 days, so n minus 1 will be a 4. Let's see if I think 4 will go into that evenly. I'm hoping. 214. And the square root of 214 is 14.628. We want to carry it out one place. They were all whole numbers, so we want to carry it out to the nearest tenth. So 14.6 degrees. So what that's telling us is the average difference between the value of the mean and the x values is 14.6 degrees. So it tells us how they vary among themselves. Now the variance is s squared or sigma squared. If we're talking about a sample, it's s squared. If we talk about a population, it's sigma squared. So in the example we just looked at right here, if we square the answer we got, we actually get the number inside the radical, which is the 214. So that we would come up with the variance. And the textbook does sometimes ask for that, so it's important for you to know that. Okay, range rule of thumb. To get a rough estimate of the standard deviation, we take the range and divide it by 4. Let's do that with the numbers we had here for our 86 minus 52 gave us 34. So if we do that, let's see what we get and how close we are to the standard deviation. So we have 34 divided by 4. And that gives us 8.5, so it's off by a fair amount, but that is a rough, and I want to emphasize rough, estimate. The second part of the range rule of thumb is actually the one that I feel is more important. It says usual values fall within 2 standard deviations of the mean. Any values more than 2 standard deviations above or below the mean are considered to be unusual. So let's look at our mean in the example we just looked at. Okay, our standard deviation was 14.6, I think. Yeah. Okay, and we want to look at, this is our maximum usual value. And this one will be our minimum usual value. So let's see if any of the temperatures in the room that week were outside. Forgot the times. 14.6. Okay, 101. 0.2. Oh, I wouldn't want my office to be that hot. 72 minus 2 times 14.6 is, and I wouldn't want it to be this cold. So those are the maximum and minimum usual values.